Good afternoon, everyone. Thank you so much for joining us for our second webinar in the Network for Youth Success webinar series. We will be recording the webinar today, and the Network for Youth Success will share the recording on their YouTube channel. And it looks like my webcam is frozen, but hopefully you can at least see me. My name is Melissa Fenton, and I am the project manager and extension educator for Click to Science. I was part of the previous webinar as a presenter, along with my colleague Sandra Ferrick. Sandra, would you like to introduce yourself? Excellent. So we're going to...
I forgot to turn the speaker on. Hello, everyone. I'm Sandra Ferrick. I'm a science education specialist at the University of Nebraska and work with Melissa on professional development for the Click to Science team. Glad to be with you today.
Excellent. Thanks so much, Sandra. Sorry, we're in the same room, so I can hear her in the room, but couldn't hear her through the speakers and didn't make that connection. So we're going to go ahead and stop our webcams just so that stops taking up so much space in the bandwidth. And we'll go ahead and get started. So our focus in this webinar is on supporting youth in constructing their own STEM identity. We're going to examine questions like, why does identity matter? What can we do to make a difference? And we're going to use a resource from Click to Science PD, Who Does Science, to frame our conversations during this webinar. If you download this resource and follow along, it is in the Files to Download pod, you will see how we have used the resource to structure our professional development experience today. The Click to Science resources in the Files to Download pod are designed to help anyone providing professional development to staff or volunteers support after-school professionals in facilitating activities that support youth in developing a STEM identity. Another resource we have shared is The Next Great Space Geologist. You can find this resource at clicktosciencepd.org or download it from the webinar. We want to invite you to register for Click to Science. Registration is free, and you have to be registered to access all of our professional development resources we have on our website. Our registrations help us count the number of people using our materials, continue to receive funding to improve and develop our resources, and calculate the reach of our projects. So it is very important that you register for Click to Science.
So we're going to be thinking about who are scientists and how do we think about scientists. This is from a research study called Who Does Science, and can they link to that in the webinar? Yep. It's in the Files to Download pod. And the research started with something you may have heard of before, the Draw a Scientist test, which was first used to gain insight in how children perceive scientists in the 1970s. In that first study involving 5,000 children, only 28 of the children in the study drew female scientists. And a lot of effort has been made to help children develop a more realistic view of scientists since then. And recent studies indicate that progress has been made. In 2010, about 40% of the children who participated in a Draw a Science research project portrayed female scientists. Today, 85 to 90% of the boys who participate in Draw a Scientist studies draw male scientists, and girls are much more likely to draw a scientist who looks like them than they were in the 1970s. For more information on this study, you can check out that link in the Downloads pod. It's titled, Students Depict More Women Scientists. Let's take a look at a couple of these drawings up close. This is actually an image from the early research of how students drew scientists in the 1970s. They tended to draw white male scientists who looked a little crazy, were making things explode, and were usually working alone in a lab setting, similar to this one. Think about these two young people from an after-school program. How might they identify with that image? Would they want to be the person in the image we just saw? Would they want to do a job like he was doing? We're going to pull up a chat pod where you can share your ideas about how youth in this particular after-school program or in your own after-school program might identify with that scientist. I'll pause for a moment to give you some time to type. Feel free to keep sharing your ideas in the chat pod because we do learn a lot from each other and from the comments that you share. Angela pointed out the scientist is working hands-on, and that's something that youth are going to be drawn to. But there's some concern, I think, in some of us that this person may not be somebody that they would connect to easily because he doesn't look like them or the people they know, the people that they interact with. And that's important, especially with younger youth, that they see images that are familiar to them. Research suggests that the view that scientists tend to work in labs and that they work alone and don't have good social skills, that their work is about blowing things up or creating weapons, viruses, or getting rich. All these views tend to discourage many young people in middle school and high school from being interested in a career in science. Both boys and girls, but especially girls, are discouraged by these sort of images. They make them think that they don't want to be a scientist because they don't want to work in a lab, or they don't want to work alone or individually, or they don't want to blow things up or create weapons or viruses. They tend to want to help people. So that's an important thing to consider in these images and role models. So here's another image that was created by a young person doing a Draw a Scientist test in 2013. What do you notice that's similar to the earlier picture and what is different? And who might identify with this version of a scientist? We'll pull up a chat pod so you can notice the similarities and the differences in this image. Any other comments about the similarities or differences with these two scientists? There really is a lot in common with these images, but there are some things that are quite different in this second image. Moment to finish typing your comments and share a couple things that I noticed. Again, we have an image of a scientist working alone in a lab, but off in the corner there seems to be something else going on. It may be that there's somebody else working in the lab with her. It's kind of hard to tell what's going on over in the corner there. One of the things that I noticed is the pictures hanging on the wall. It looks like they're put there more carefully, more intentionally. They're more decorative than the pictures in the first one. It just seems a little bit more professional in a setting or a context. She looks calm, like she's doing something nice. She's not quite as crazy looking as the first scientist, but they both look like they're having fun, that they enjoy their job in this setting of being in a lab. The beakers with stuff coming out of them, that's similar across both of them. So they're still portraying a chemist working in a lab. That's very similar, but it's got a different feel to it. And what we want to think about with these images is how we can help young people perceive scientists as people who work as part of diverse teams, who solve problems and help people. The rate of boys and girls who are interested in being a scientist increase when they have these views of what the work of a scientist is. And girls in particular are very interested in areas of science that help people and make their lives better. I selected a couple of research studies that I found helpful to include as downloads if you'd like to read more about the relationship between young people's age, gender, and attitudes towards STEM. It'll help you understand why we've identified late elementary and middle school years as an important time to focus on STEM identity. So let's think a little bit about what identity is and what it means. Why is it important for youth to develop a STEM identity? Well, what does the research tell us? First, there are several research studies that have shown that out-of-school time programs can have a significant impact on STEM identity. In the web links pod, there are links to 2 after-school programs that focus on developing STEM identity and the impact they've done they've had with youth. And both of them have done some good research on the work they're doing, and share that on their websites at Project Exploration and Tech Bridge Girls. Both good sites to look at, especially if you're interested in this idea of developing identity. Second, though the experiences of individuals differ, especially by race and gender, there is a trend across studies that late elementary and middle school years are a crucial period for developing a STEM identity. For all young people, this is an important time. We don't understand exactly why this is and why it happens at this time, though it is developmentally when youth are developing their identity. But as students are finishing up elementary school and going into middle school, this is a time when they start deciding that they're not a person who does science or math, and that that's not the type of career they have. And the concern we have with that is not that we think every student should view themselves as someone who's going to have a career in science, but if they start opting out and not taking science and math classes or not taking challenging classes, then later, if they change their mind and they decide they want a STEM career, they may find they aren't well prepared because they didn't take enough math classes or they didn't take challenging classes in high school, and so they don't have the background they need for the sort of career options that they'd like to pursue. So our goal is to engage youth early and then keep them engaged in STEM through middle school and high school, because this opens up opportunities for them in college and technical school and beyond. Depending on what they want to do, it just gives them the option to pursue that area of interest. That's why we think it's important to encourage students throughout elementary and middle school to be problem solvers, to be data collectors, and to use their science and math skills. We also recognize and need to address the differences in the experiences that minority youth and girls may have had coming into our programs so that they receive additional support if they need them. The goal is to help youth continue to see themselves as a person who does STEM throughout these critical years. They may not choose a STEM career when they finish high school, but they should feel that they're prepared and they can be successful in STEM if that's what they want to pursue. And they should know that there are many different types of STEM careers that may let them work in a lab or in a factory or outdoors or in an office, so there's different options they can pursue. And there are many STEM careers that pay well, and some require an apprenticeship or a 2-year degree, while others are going to require them to have a 4 or 6 or more years of schooling, depending on what they want to do. We just want them to have this full range of options open to them. And identity matters to what young people in our programs are able to accomplish, because identity impacts the options that are open to them in life and the paths that they can choose. So that's really what we want to emphasize here about why identity matters.
So I want to reinforce that in after-school programs or out-of-school time, we can make a difference, specifically in what we do and what we don't do in our programs. There are 4 fundamental experiences we can provide youth to help them develop a strong STEM identity. We can make a difference by getting young people involved in STEM topics and professions. We can introduce them to STEM role models in person or via videos. We can support them in developing a sense of competence and confidence in solving problems and answering questions. The youth in our programs need to see themselves as contributors and participants in STEM. So this means that they need opportunities to find real answers to questions that matter to them, to engage in citizen science projects, in project-based learning, or to design solutions to real-world problems. We must provide opportunities for youth to collaborate together to solve problems as part of a team. So we'll go into each of these areas in more depth throughout the webinar, but first I wanted to ask you if there are things that you are personally doing in your after-school programs to help dispel some of the negative stereotypes about science, engineering, and math. We pulled up a chat pod there on the screen titled Dispelling Negative Stereotypes, and want to hear what you do in your after-school programs, specifically some ideas that either you've done in the past or you're thinking about doing, or anything that you've read about that you want to share with your peers to help us dispel some of the negative stereotypes about science, engineering, and math. So I'm going to go ahead and mute my microphone and give you time to type. So we have a lot of great ideas being shared, so keep sharing those in the chat pods while I discuss some of the ideas that we had shared here. So we've a couple themes that adults and youth can work together to solve the problem or to answer the question as co-inquirers. If you're the adult in the group, then you are showing them that you do science too, or you do engineering too. And I think that's important, especially if you relate well to the youth in your programs, that they see you as someone who does STEM. We also talked about math games, including STEM in daily programming, so not just exposing them to STEM because they signed up for the robotics club or they signed up to be part of the science club, but that it's integrated into our daily programming. And then, of course, having hands-on fun activities where they get to engage in STEM and see how it can be a really fun opportunity while they're both learning and experiencing something new. So great suggestions and strategies there. I'm going to go ahead and hand it over to Sandra, who's going to take us through a discussion of some STEM role models for our next segment.
Sorry, I forgot to turn my mic on. Suzanne had a great lead in with her comment about exposing youth to different role models. And these two role models happen to focus on women in STEM. And we'll share with you some resources specifically to support that idea. But they also represent different ethnic and racial groups so that hopefully more of our students can identify with them and have these role models look like people they interact with every day. So we're going to look at this strategy in a little bit more detail. We've gathered information about a couple of STEM role models, and we're going to share that with you. The first one on the left is Fatima Jackson, and she is a biologist who studies plants. She studies common African plants that are used as food and medicine, and her work takes her to many countries and has led her to study local foods such as cassava, which guards against outbreaks of malaria. She takes samples of these foods back to her lab at the University of Maryland and investigates the chemical makeup of the food to learn how they work and how they help keep people healthy. One thing about plants, she says, is that they can't run very fast. They can't run at all. So what they have developed are chemicals that draw insects or animals that would help them survive towards them or keep animals away from them that might hurt them. The chemicals that keep you away are called repellents, and the chemicals that draw you toward the plants are called attractants. And it's just an example of some of the work that Fatima does. And on the right, we have an image of Adriana Ocampo. She's a geologist who's interested in studying the geology of other planets. She's a space geologist, and her mission in life is to explore other worlds, even though she's never traveled to those planets that she's studying. She helps us become better acquainted with the universe and with ourselves. The next great space geologist, one of the resources you can download from the Files to Download pod at the top of the page, focuses on Adriana's work. Adriana grew up in Argentina, and from her window she often wondered about the night sky. I couldn't go to sleep in the evening without looking at the stars and wondering what those little points of light were, she says. Adriana was interested in how things on Earth was interested in things on Earth and in space. Her favorite subject in school was science, but schoolwork was often very hard for her, especially math. But her math teacher wouldn't give up on her. Adriana remembers, she would make me keep working until I understood everything. Adriana was still in school when humans landed on the moon. She remembers the exact date, July 20th, 1969. On her TV in Argentina, she was watching astronauts walking around on another world for the first time in history. What fascinated her most was the surface of the moon and its unusual rocks and soils. From that moment on, she was hooked on understanding the geology of other worlds. Both of these scientists do interesting work, and they serve as excellent role models for the youth in our program. Melissa's going to talk with us a little bit more about role models.
So now that we've introduced some role models, the important part of including them as part of your STEM programming is that you relate them back to STEM learning experiences. So I want to take some time to brainstorm some different STEM learning experiences that you can connect to each of these different STEM role models. It's important that you connect what they are doing in after school to what the role models do to truly see themselves as someone who does STEM. So Sandra's going to pull up a couple of chat pods, and we want you to share some ideas that you have or some STEM learning experiences or activities that could relate to a plant biologist and a space geologist. So if you have a link to a website or other information about the learning experience you are suggesting, please share those as well so that everyone can utilize these lesson plans in their programs and connect them to the role models that we've shared with you today. So I'm going to give you a little time to think about that and also share your ideas in the chat pods, and then we'll also share a couple ideas as well. So I don't see anyone else typing, so we'll go ahead and thank Suzanne and Sarah for sharing some activities there and some links to some websites. Also put in the link to a NASA site that has some STEM lessons from space, and also shared the Exploring Soil Ecology activity from the Click to Science website. And our plant biologist, Sandra, shared an activity about trying cassava to measure how much starch was in the foods. I'm not sure what she's talking about, so I can't comment on it, but if anyone remembers doing that activity, feel free to share that. And then I had found an activity in preparing for this webinar that was just a leaf hunt, and so youth walk around and gather different leaves and plant types and then try to identify them and talk about the different characteristics that make up different plants. So it's a very simple activity, doesn't take a lot of supplies. You can go outside at your location and do that.
Strategies that we can use for helping youth develop their confidence and competence in their ability to solve problems and answer questions. When youth are solving problems, it is important that they own their solution and that the solution works. You build confidence when you demonstrate your confidence that you can solve a problem, and your confidence that they can solve the problem, and you don't need to come up with the solution for them. You may need to allow extra time for them to test their solution and maybe change it, but it's important to give them the ownership. When youth connect with role models that they find relatable, whether that be virtually or in person, they begin to see themselves differently. A role model doesn't necessarily have to be the same race or gender to be relatable, but connecting with that person in some way is essential. Since we can't always know who youth will connect with, having a variety of role models is really important for them. When youth collaborate as part of a team, they learn together, and they also develop skills in communicating, empathizing with others, and seeing things from different points of view. Research tells us that youth respond strongly to hands-on collaborative STEM activities. They're engaging and fun. When they enjoy working as part of a team to solve a problem, they develop their sense of competence and confidence in STEM.
So now we'll move on and talk about being contributors and participants in STEM. So we have a Click to Science video to share that shows youth engaged in a project-based learning experience. The facilitator does a great job of connecting what the youth are doing in their robotics projects to projects and applications in the world. This helps youth to see themselves as contributors and participants in STEM and think of how these skills relate to real problems. So we're going to watch the video together and share the strategies the facilitator used to make connections between what they are learning about programming robots to careers and problems in the real world. If you have trouble watching the video, it is not available in the web links pod, but we will share a link to it in the chat pod. And I'm going to go ahead and get that video pulled up now, and then we will play it for you. So Brian, in your room, you may want to click on the link that we're going to share in the chat pod and watch it on your own. So I'm going to go ahead.
supposed to go forward, and then it's supposed to turn to your left. It's supposed to avoid 3 obstacles.
Providing real-world application of the skills of an engineer is an important strategy when developing a STEM identity in youth. Watch as a volunteer engineer gives youth real-world engineering application of the project they are doing in robotics. Listen for the challenges he gives youth to think deeper and try to solve problems using redesign. Notice how he does not solve the problem for them, but lets them work through the project on their own.
Now, what did you do to make that travel just a few feet and stop?
The way that it was set up, it was this one, and I had it going forward.
And that's going to run for how long? Forever. If you tell a robot to do something forever, at some point you have to tell it to stop. You can lose that robot. The U.S. Navy ran into that. They had one of their unmanned vehicles, and it communicates back and forth. The people on the boat expected that robot to go left, and it went right instead. They didn't let it run forever. If it went 2 minutes without being asked, "Are you there?" it surfaced. So 2 minutes later, it surfaced. It said, "Come pick me up. You guys messed up."
So do we need to turn right or left? Right. So what I changed is the direction that it will be turning and the length, like how far it goes. At this time, it should move backward if it sees an object right in front of it. Didn't go the way that I wanted it to. What I had done was, this is the left motor and this is the right motor, and I told only the left motor to move instead of both of them to.
One of my favorite quotes comes from Albert Einstein. Keep everything as simple as possible, but not simpler. What is the software doing?
It goes forward, it senses, goes backward, then goes forward.
Can you make it any simpler than that?
No.
I don't think so. So download that and see how it works. It's avoided its second obstacle and a third. Good job. Think about a practical application. How could going towards something, stopping before you get to it, help somebody in the real world?
Maybe for somebody who can't see, like for a blind person.
Can't see. In the 1970s, they built a walking cane that used an audio output. So that's one application.
So I hope you all were able to see and hear the video okay. I'm going to go ahead and get rid of this video and then pull up a chat pod because we want you to share the strategies you saw the engineer use to connect robotics and the real world problems. So Sandra is on top of the chat pod and has it pulled up there. So what did you see the facilitator doing? What did you hear the facilitator saying to reinforce that connection between STEM learning experience and the real world problems? So I'm going to be silent for a little bit to let you share your ideas in that chat pod. So I'll give you a little more time to share the strategies that you saw this facilitator using in the video. But I thought he did a really nice job of using all of the strategies that we talked about to develop a STEM identity. So they were involved, in a STEM activity. He was an engineer, so he could talk about his perspective on robotics and designing solutions to problems as an engineer. He allowed youth to work through the problems instead of giving them the answers. So I think you saw several times in the videos where he would ask them questions to help them think more deeply about what they were doing so that they could solve the problem. He, like Angela mentioned, gave the youth time to try the solution so that they could test it out for themselves. So he really helped them develop a sense of competence and confidence and to see themselves as contributors and participants in STEM. So by asking them about the real world applications of what they were doing, he was connecting it back to how this could make a difference in the lives of others. So what they were learning with robotics, while it was also fun to make the robot do what they wanted it to, also could be helpful to other people in possible other careers. And they also were working together. So you saw groups working together. I mean, it focused on the one gal in the blue shirt, but the others, they were working on teams to program their robots and test them out. So he did a nice job in the activity of kind of fostering their STEM identity by doing the things that we've talked about today. So I'm going to go ahead and get rid of the chat pod, and then we'll move on and talk a little bit about collaboration. So another strategy that we shared was to give youth opportunities to collaborate together to solve problems and answer questions as part of a team. Sometimes getting youth to work together is difficult, and we all know this. Click to Science has resources around the skill encouraging collaborative STEM work to help staff foster teamwork and collaboration in youth during STEM learning experiences. There's a link in the web links pod to more about this Click to Science skill if you are interested in exploring that further. One important note about collaboration contributing to STEM identity is that the solutions and answers youth develop should be relevant to them. So for example, if your community is trying to increase participation in a recycling program, ask youth to help solve this problem. What kind of device could they design to help more people recycle? And here are some additional tips for helping youth collaborate. So we've received this strategy from a program that is based out of Nebraska and also works in the same building as us, but they really deliberately group youth into teams based on how they know them. So they observe the youth the first day before they come in to do their nutrition programming and see if there are youth who appear to not be working very well together or have an already established click, and they split these youth up to set them up for success in working together with others. They also talk with youth using positive language to create a collaborative learning environment and encourage youth to talk to each other and model how youth can collaborate together. So when working on STEM, it shouldn't be silent, it should be noisy. They should be talking and discussing different ideas for solving the problem or for answering the question. And also give youth real-world examples of collaboration in STEM. So some activities ask you to assign youth roles. There is an activity on the Click to Science website where you can connect them to careers as a geologist, a structural engineer. So you can assign youth roles based on what you know about them. For a recycling device design challenge, perhaps one youth could be the project leader, making sure each person shares their design ideas and that everyone agrees on the design. One youth could be the engineer, drawing the actual device, and one youth could be the researcher, looking up ideas to share with the group for the device. So by assigning them roles, you're making sure everybody is participating in the activity and feels like they have something important to contribute. So as our final brainstorming topic, please share some ideas for problems you could present to youth that they have to find a solution for. So we're pulling up a chat pod titled Real-World Problems, and we want you to share some ideas for some real-world problems that you could pose to youth in your programs and ask them to solve or answer a question that would help solve this real-world problem. So I'm going to be silent for a little bit to give you time to think about that and to share your ideas with your peers. We've got some good ideas being shared. Definitely problems with pollution and how to encourage recycling or pick up trash are always good to connect. Unfortunately, that's a problem that we've been facing for a long time, so it's always relevant. I liked Debbie's suggestion of ways to make walking around a neighborhood easier for the disabled. That's a great idea for connecting that to some STEM activities. Energy savings at their schools, how to shut down computers or unplug appliances. Do an energy audit. That's a great idea, Sarah. Sandra suggested developing a composting program for the lunchroom, as this is a specific need at the school. In our last webinar, someone mentioned the Flint, Michigan water crisis as a real-world problem to frame a water filtration activity. So we had examples from a water filter, building a water filter activity that we have on the Click to Science website, and we have some videos of. And they mentioned that, talking about that and what happened in Flint could be a great way to talk about the importance of clean drinking water. Sandra also suggested using GPS to mark the resources in the community and identify if there are areas that are underserved, and that's a great idea to get them out walking around and exploring as well. So there are a lot of ways to frame the STEM activities that we do, and giving them a real-world context makes them feel like those users and contributors to STEM. These are problems that relate directly to them, especially if they're in their local communities or they know someone that it's affecting. Maybe they have a classmate who's disabled, or they have someone in their family. So that challenge could really resonate with them. And I think that's a great way to connect with your youth and help them develop a STEM identity. So we want to thank you so much for participating today. Please take some time to open the web links and download the files from the download pod. There are a couple research studies in the files to download, as well as a couple of Click to Science resources. And then the web links are to the Click to Science site, a blog post discussing the new Draw a Scientist test, and then links to Project Exploration and TechBridge. And then also don't forget to register for Click to Science and subscribe to our newsletter. You'll get the most up-to-date information about new content. If you have any questions, please type those into the chat pod and we'll try to answer them. A recording of this webinar will be posted on the Network for Youth Successes YouTube channel. And our next webinar in this series is March 7th, 2017, and we will be focusing on cultivating local STEM partnerships. So I want to thank you again for sharing your ideas with us and your peers. We all have expertise to share, and we appreciate all the great ideas and resources that were cultivated and shared today. And we hope to see you again in March. Have a great holiday season and a Happy New Year.